Yeah. Yeah. Now, something, and it always is nothing. So if we look at this here, are there any questions on the homework before we get started with today's lesson? A matrix is a rectangular arrangement of numbers. The dimensions of a matrix with m rows and m columns are m by n. Rows, columns. Up and down is our rows, so rows by columns. It's how we list this. M by n. So this here is a 2 by 3. 2 rows, 3 columns. Down and over is how we define the dimensions of a matrix. Questions so far? A matrix derived from a system of linear equations, each written in standard form, with the constant terms on the right, is the augmented matrix of the system. For example, the system below can be represented by an augmented matrix. So if we look at this one here, you guys don't have to write this down because once we start doing these, we're not going to need to do a whole lot of practice with them. Because if we look at this matrix, the first equation is 5x plus 3y minus 2z equals 1. So the numbers are 5, positive 5, positive 3, negative 2, and 1, yes? Let's look at the matrix. Positive 5, positive 3, negative 2, and all we need to make sure is that the system is in the form of x, y, z, and the constant term, the number without a variable, is on the right side of the equal sign. As the next one, 1, positive 1, positive 2, positive 3, negative 1. 1, 2, 3, negative 1. If a variable does not show up, if one of these equations was missing an x, y, or z, what number would we put in its place? 0. Because if a number's not there or a variable's not there, it is 0. So this is our first example. Yes? So we want to write it as an augmented matrix and then state the dimensions. So the first thing we want to make sure is that we do have x, y equals number, because we only have 2 variables here. Is the first equation in that form? No. So what do we need to, how do we need to rewrite this? Well, we just need to switch the x and y, yes? Negative 2x, then plus y is equal to 1, because the sign in front of it sticks with it. Because since we're saying x minus, or y minus 2x, so if we just think of the numbers, it's 1 minus 2. So if I flip those, it would be negative 2 plus 1, because that negative is attached to the 2. So now is the first equation written in the right form. Because we have x, we have y equals number. Now the next one, do we have x, y equals number? Yes. Yeah, because x, 3y equals 12. Because we had to switch the first one because x didn't come first. Because with all the equations, really, the variables, like the letters, the way we put it, doesn't matter too much. We just need to make sure they're all the same. And for the most part, the way that we want to do it is kind of alphabetically, by the English alphabet, A, B, in that order. So we'll go X, Y, Z. Okay. Or we could go M, N, O, kind of in that order. And it's going to come back, especially once we start solving the order. Now let's write the system. So we'll start off with a big brace, or well, bracket. We have a bracket. And we're just taking the coefficients, we're just taking the numbers. So if we look at the first equation, its coefficient is, and then y's is, positive 1 equals, let's do the next one. So x's number is, then 3, and you have now written an augmented matrix. Almost. Well, because write an augmented matrix for the system. Then state the dimensions. Rows by column. So how many rows do we have? Now we finished. Yeah. Questions on this here? So let's look at this one here. So write an augmented matrix for the system, then state the dimensions. Well, are both of these equations in the right form? No. Well, if we look at them, the bottom one is x, y equals number. It's kind of in the correct form. X, y, well, we don't have z, so we don't have to include it. But the top one, we do need to switch the x and. So its actual equation would be 3y equals 13. We just have to rewrite it so that it is in the form x, y. If there was a z, we would include it equals a number. Now, I did say earlier if we're missing a variable, we have to put it in as 0, yes? Now, that only comes into play if that variable shows up at least once in one of the equations. So if one of these equations had z, so the top one had x and y, the bottom one had y and z, I would need x, y, and z. If it shows up, we include it. But here, is z included in either one? So we don't need to list it.
We're going to do an example with z.
Now we can write the dimensions, or write the matrix. So the first row would be what? And then the bottom would be? 4, 3, 13, 2, negative 1, 5. Now, probably for some of y'all, seeing how that switched, you could see that already. I mean, if you can see how to go from these two here straight to this here, that's fine. You can do that. But if it helps to rewrite it, so you see the sign, see which one's which, rewrite it. There's nothing wrong with rewriting it back out in the correct way so that we can see how the numbers actually look. Because it is very easy, especially once we get to 3 variables, where we're looking at 4 different numbers, because the 3 numbers with the variables and 1 on the other side, it can be confusing on what signs what. Now the dimensions of this are 2 by 3. We go down 2 over 3. You ready for the next one? We have 3 variables now. Are all of these in the correct form? Because we have 3 variables, so we need the form of x first, then y, and then z.
No, they're not.
So we need to rewrite this first one, yes? Now up to this point, we've been able to just move them back and forth because they're on the same side. But this time, the 2z, because 3x is fine, the negative 4y is fine, equals 7 minus 2z. This side is not in the right spot. Z is not in the right spot. So we need to move it to the other side, yes? I'm going to write this over to the side so that we can kind of see this. How can we move the z? Yeah, we can add it to both sides, yes? So I can add 2z here, add 2z here. Negative 2z plus 2z will cancel, telling them this is equal to 7, yes? Let's just keep it in standard form. 3x minus 4y plus 2z is equal to 7. So this is now taking the place of that equation.
Just do the 0 before the z.
Yes. So let's do the top one first. So if we're looking at the augmented matrix, well, Are there any questions before we do the augmented matrix? So let's look at the augmented matrix. So for our first row, we would have what? 3, -4, 2, and then 7. Now I always put the second bracket after I write the first row. The reason I do that is to give myself space. Because it's easier once I write those first set of numbers out, it'll give me a spacing because the rest will have the same number. Now the second row, we'll start off with 9 for x, positive 3 for y. Since we don't have a z, we have to put in 0 equals 3. So that is something to pay attention to, x, y, z, because if you start just writing the numbers down, you'll sometimes get yourself off on the spacing. Now the next one, the x is 4, -1, and 2. And what are the dimensions for this one here? 3 rows, 4 columns. Now, we are able to pull matrices up in the graphing calculator, and we'll see that in a minute. And that's sometimes a good way to check it because it'll give you the visual of it. Because sometimes it's easier to get these flipped rows and columns. So if you pull the graphing calculator up, and I'll show you how to put one in, and you put it in there to see what it looks like, we can kind of tell which one's which. Yes, they are pretty heavy. Questions on any of this so far? We ready to look at one more? Because I think probably one more and we'll feel good with these here. We'll finish off with this one here. So are these 3 equations written in the right form? Yeah, because all 3 are written in the form of x, y, z equals number. Yes? So we can go straight to the augmented matrix. So the first row is 3, 1. The next row, 2, 1, 4, and 2. And the last one, 7, -3, -6. And this is a, all right, 3 by 4. Questions on this here? Feel like we're good with these here, yes? Solving systems of equations using technology. We can use technology to solve these systems of equation. Now there are some steps to it, because what we'll end up getting is something like this here. Now, what we said is we put x first, y, then z, yes? So if we apply the x, y, z back to this here, well, the first one would be x, 1x, yes? Plus 0y plus 0z is equal to -1.4, yes? So what's the only thing left in that row? X is equal to -1 point. If we go down to the next one, well, we'd have 0x plus 1y plus 0z. So y is equal to, and the last one, 0x plus 0y plus 0 or 1z, or just z, equals, so z is equal to, so for this here, 1.4, comma 5.2, comma 16 is the ordered pair solution for this here. And that's part of the reason why we put it in that form, x, y, z, to where when I get the solution, I can go straight down x, y, z, I have my ordered pair, ordered triplet. Questions on this here? Now, I would make sure the graphing calculator is turned on at this point. Now, solving a linear system using technology. The first step, we want to write the system as an augmented matrix. Step number 2, enter the augmented matrix into your graphing calculator. Step 3, use the reduced row epsilon form. echelon form. R, R, E, F. So reduced row echelon form is getting the matrix to look like that. Now you're not going to have to do that by hand. If you take calculus, they'll show you how to do it, or pre-calculus, I'll show you how to do that. I won't make you do that because it is tedious and takes a lot of time. But we're going to get it into RREF. Interpret the results from step 3 to solve the linear equation. Okay. So if you flip to the next page, now on your note sheet, you will notice at the bottom of this next sheet, there are steps, yes? That's what we're going to do together. But I have them there just so you can refer back to them in your notes when you start working these here. I'm going to have my own note sheet because I'm going to forget this. So the first part is we have to rewrite this in an augmented matrix. So if we look at the 3 equations, we have XYZ, 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 and our numbers on the other side, yes? So we can rewrite this as an augmented matrix. So let's write this here as an augmented matrix. Well, the first one is going to be 1, 1, 1, 2, yes? The next row is 2, 3, 1, 3. And the last one is 1, negative 1, 2, and negative 6. So we have the augmented matrix, yes? All right. Now that we have that, we'll pull the graphing calculator up. Now the first thing we need to do is input the matrix into the calculator. Okay? Probably it's dead batteries. Now if the batteries do die on these, let me know. I do have extras. Unfortunately not for these. If we replaced them with rechargeable batteries, possibly, but AAA rechargeable batteries are too expensive, or more expensive than what they're worth. So now the first thing we want to do is input this augmented matrix. So the first thing we're going to hit is second matrix. Second, and then that x to the negative 1. And we should get this here. Now, most likely, yours might have stuff written in like 3 by 4 numbers on there. Or 3 by 3, or it could have nothing. Yeah, that's fine, because that's just if something's been put in. Now, what we want to do is we want to input this matrix. We want to edit. So we're going to go over to edit. Now, we have many different matrices we can put in. It's not working. Oh. There we go. I turned it off and turned it back on. So we get over to here, yes? So we can input different matrices in. We can put pretty much as many as there are letters here. But for us, we're going to put this in the first one, A. Now, the dimensions of our matrix are a what? A 3 by 4, yes? We have 3 rows, 4 columns. So the first part where it's blinking up here, we need this to be a 3. You can hit 3 and then enter by 4. And when I said earlier, we can kind of use this to see if we got the dimensions right, because if we look at this here, okay, I do see spots for all of those where we have them, yes? We have 3 going down, 4 going across, so we can check it. Now, if we look at the first one here, our first row of the matrix was what? 1, 1, 1, 2, yes? After each number, you can hit enter. So I can hit 1, 1, 1, 2. Because each time you hit enter, it'll move it over 1 in that row. Whenever you get to the final end of the row, you hit enter, it'll bump you down to the next one. For that one, we can do 2, 3, 1, 3. It's not, it's there. One, two, three, four. So one, one, one. There's one, two, three, four. You just can't see it all at the same. Yeah. The screen on this won't let you see all 4 rows at the same time. But this one is just a different model. So after you finish typing the first one in, go on type the whole thing. So 1, see here, -1, -2, and -6. When you're typing the negatives, make sure to type in the -1. Don't do minus. Because if you, it's down by 0.
It's by the point.
Yep. Because the calculator will tell you immediately if you use the wrong one. Because if, here, I'll do it for this one. If I said -1 and hit enter, it'll say syntax error. That's not right. Now, most of the time you normally hit quit. Does anybody know what this word says here? Go to. I always thought it was gato, but it's go to. What that does is it takes that little cursor to where the error is, letting you know this spot right here is wrong. So then you can hit minus, enter. Or, well, we wouldn't want it negative, it's just 1. So any questions on this here so far? So we put the matrix in, yes? Everybody get it put in? Now the next thing we'll do is second quit, second mode, because we want to quit out of that. Now what we want to do next is actually solve this, all right? Now to solve this, we're going to go, again, second matrix. Second matrix. Once we put it in, we're going back second matrix. But this time, we're not going over to edit. We're going over to math, the one in the middle. Now you can scroll up or down. It doesn't matter which. What we're looking for is RREF. RREF, and it's going to be close to the bottom. So most of the time, I will go up. So right here, RREF. Once you get the spot next to it highlighted, hit enter. And it should pull up just RREF, yes? So this is telling the calculator. Yep. So second quit, second mode, second matrix, go over 1. And scroll up or down to RREF, and then hit enter. So what we're telling the calculator is to change the matrix, or whatever matrix we put in after this, into row-reduced epsilon form. Well, we're going to have to do this again, second matrix, because we need to name a matrix. Well, which one do we want to name? A, so we can hit enter, and then hit enter one more time. I'll look at it. Or it might be just if we look at the or go to. Go to, it's going to come back here. Second matrix. So you named it as C.
So I put it on one. I don't know what
It looks like it defined it as C. So second matrix. We'll go down to C. Yep. It just put it in as C instead of A. But it doesn't matter. We're just defining one of them as it. Now, what this tells us is that the solution is -1, 1, 2. As long as we did X, Y, Z, it should give us this here. Yes, sir. So second, we can scroll down. Second matrix. We go over to math, and we can go up or down to RREF, and we'll hit enter. Now we go second matrix. Since you defined it as C, we'll call it up, and now hit enter one more time. And that's it. So since we did this in the form, the first variable was x, second one's y, third one's z, x, y, z. The first number on top is going to be x, then y, z. Negative 1, 1, 2. So the solution for this here is negative 1, 1. And that's the system. That's for solving the system. And that's it. Yep. Yeah. So, so this is the value of x, y, and 2. Yep. Well, when the matrix came up, that's it. Yeah. Because what we're saying is that, because again, we said x, y, z equals our numbers, yes? So the top row is telling me that I have x plus 0y plus 0z equals negative 1. So the value of x is negative 1. The same thing is true for the middle row, which is telling us y is 1, and the last one's telling us z is 2. So our solution is negative 1, 1, 2. And that's it. So it solved it for us. Now let's flip to the next page because the bottom doesn't have a problem on it, but those are kind of some of the stepped out versions of what we just did, just so that you have it as kind of a reminder what we did. Now, yep, so those are the steps. Now if we look at this here, do we have it as x, y, z equals a number on each one, yes? So is it essentially already an augmented form? Yeah. Okay. Do we necessarily need to rewrite it as an augmented form? No, because we know the first number in the first row is going to be what? 2? Yeah, if it helps, rewrite it. Yeah. If not, I can look and say the first row is going to be 2, 3, negative 1, 15, yes? So we can pull the calculator up. And again, we can go second matrix and go over to edit and hit enter. So we still have a 3 by 4, yes? Yep, 3 rows, 4 columns. Because any 3 variable system is going to be a 3 by 4. Now our first row is 2, 3, negative 1, 15. Our second row is going to be 3 for x, negative 9 for y, 9 for z, and negative 12. And the last row is 4 for x, negative 3 for y, negative 1 for z, and 19. So we got this here. So second matrix, yep, you can go left or right, either one works. One more. Yep. You can get it the first one or second one, it doesn't matter. Now, especially if you're doing multiple of these, it's good to edit the same matrix for the next step I'll show you. So, did we get it typed in? Second quit. Once you get it typed in, hit second quit to get out of this mode. Okay, now, if we've done this once already, because we see right there we've got the other solution and RREF A above it. Now, if I put that matrix back into A, here's a little shortcut we can use. I can go up, up. We can scroll up twice and highlight that. Hit enter and let's see what happens. It pulled RREF back down, yes? And A. Did we just change what the matrix A was? For those that use A, I hit enter again. Because if I already had it typed in, I can highlight it, bring it back down, and do it again, because matrix A is not the same as we had it. We changed it to something new, yes? But again, I will go through the same process also if we didn't do that, because we would go second matrix. Yeah, over to math, and we can scroll back up to REF and hit enter. Then we go second matrix and pick the matrix that we want and hit enter, and we get this here.
So you do like multiple processes.
Yeah, and don't have to keep, if you have it already typed in once. Now, there are other things that you probably saw in math, because the first one, DET, is determinant. We'll get to those eventually, taking the determinant. T, does anybody have a guess what DIM is? Dimensions. So if I want to find the dimensions of A, we can do DIMA, enter. It is a 3 by 4. So we can actually have it figure out the dimensions.
It's pretty obvious.
I mean, once we start doing some multiplications and addition, subtraction, it'll help us a little bit. For matrices? Any other questions on these here? Do we need to see one more of these? All right. If we feel good with this here, we'll go on and move on. Now, again, if we're missing variables, the number that goes in its place is 0. Yes. Yep. Give me 1 second. I will fix that.
Oh my gosh, these are beautiful now. Have a whole different perspective.